Hello and welcome along to this video tutorial on advanced modeling. So this is specifically going to be about modeling BPMN and then executing those symbols. So far I've done a few tutorials in which we actually built models and deployed them, but none of them particularly complicated. So now we're really going to show you some of the power of the BPMN symbols and specifically those symbols in execution. My name is Niall Deehan. I'm an international consultant with Camunda, and on my arm there is a hawk called Smoke Man Muscle. So there are some prerequisites for this video, meaning that I'm not going to jump into the very beginning. I expect to understand a certain amount about Java, a certain amount about how to make REST calls, and Camunda basics, things like how to start up Camunda, how to model, how to download that sort of stuff, and of course the very basics of BPMN, understanding the concept of tasks and gateways and things. The constructs we're actually going to talk about in this particular video are going to be the non-interrupting boundary event, this guy here. We're going to talk about the event-based gateway, the message event here, an error event, throwing and catching them, call activities, which call subprocesses, and my personal favorite, which is the event subprocess, this guy here, along with the conditional event. So these are the things we're going to model, we're going to use them in a particular scenario, and we're going to execute them. Okay, so let's get started. So I'm continuing from the point in which I left off in the Java developers tutorial from earlier. So this means that if you didn't follow the tutorial, what you need to have is the Camunda platform downloaded and running. You need to have Camunda's modeler, and you need to have a Java project created in whatever IDE you use with a process model inside it. That's the point in which we're going to begin. So if you'd like to go back and do that tutorial, go ahead. Otherwise, just get to this point and then you can follow along. So the beginning of this, of course, is going to be I'm going to create my model. I'm going to open up this process here. So this is the model I currently created last time, which is just checking the weather. I'm going to create a new tab. Okay, and I'm going to start building this model. So we have our start event first of all. So the next thing I'm going to do is I'm going to add a, which is in this case going to be called create podcast. Okay, so next we're going to have a task. I'm going to change this to a user task, which means that some user is going to need to do something here before we continue. And I'm going to call this travel to Foon. Okay, so on this task, I don't want this to, I want to be able to make sure that while we do this task, we are also at the same time waiting for an event that may occur. The specific event in question is I'm going to drag and drop a intermediate event from the panel here, and I'm going to convert that into specifically a non-interrupting timer boundary event. Okay, make sure it's non-interrupting. So you'll see that it's got little dashed lines around it, and I'm going to give this a timer which is going to say every 20 minutes. Okay, and I'm going to select the timer itself, and then using the context menu, I'm going to select a task and drop it here, and this task is going to be another user task, and it's going to be called get something to eat. Okay, and then follow that off with an end event, again from the context menu. So what this means from the BPMN perspective is that we start this process and then we have a task called travel to Foon, and while this task is active, we will wait for 20 minutes. In fact, we wait every 20 minutes, and every 20 minutes in parallel to this task being active, a new token will be formed which will actually go down here, and then we'll get something to eat. Okay, so if we're on here for 40 minutes, obviously this timer will fire twice. But if we leave before 20 minutes elapses, this timer will never fire and we'll never get something to eat. Okay, so next up I'm going to add a subprocess. This is an embedded subprocess. So you can see it's from this section here. So I'm then going to connect travel to Foon to the subprocess. Now the subprocess is not calling another process somewhere else, it's embedded, so it's part of this model, but you'll see very shortly now why it's actually really useful. a subprocess needs a start event, and it also needs an end event. Okay, and it's important what we put in between here. The first thing I'm going to add is I'm going to select the task here, drag it and drop it in between here. Okay, and then convert this to a call activity. Okay, so this is going to call another subprocess. Those of you who may remember, we actually already have a process in our context. If we take a look at the Eclipse model, it's called process.bpmn, and we built a process where we check the weather. You can see here. So I'm going to call this process. So I'm going to go back to my new process here, and this subprocess is going to say check the weather. Okay. So it should be sort of known that when we do actually run this process, the parent process, which is this guy here, will actually wait. The token will wait until this check weather process has completed before moving forward. And when that does happen, we're going to wait for some events to occur. And to do that, I'm going to move this event across. I'm going to drag and drop a gateway. And then I'm going to use the morph tool here to change this to an event-based gateway. So what I want to do here is wait for a message to tell me I can continue, or wait for a timer to go off, which is going to tell me to continue in a different route. So if you select this context menu, this event-based gateway is like an XOR gateway, but instead of using data to decide which way to go, it waits for one of 2 or more events that may occur. Once one of those events happens, the process will continue in that direction. In this case, the 2 events we're going to wait for are a message event called Usidore and Chunt have arrived. They'll move here. And the second thing we're waiting to happen is that if they haven't arrived by a certain time period, let's say 30 minutes, then we are going to go up here. Okay, so once again, what's happening here is that we start this sub-process, we check the weather. Once we have finished doing that, we arrive here, in which case we are waiting for both a message to come in, that Usidore and Chunt have arrived, or we're waiting for 30 minutes to elapse. In this particular model, I'm going to decide that after 30 minutes has elapsed, I do not want the process to continue as normal. Instead, I would like to somehow redirect the process. And to do that, I'm actually going to use an error event. So I'm going to move this across, I'm going to morph that into an error event. So this is still an end event, but now when a token arrives, the token is consumed, but it also produces an error that will then propagate up to the next scope to see if it's caught. And this is going to be podcast cancelled. Okay, now to catch this error, I need to go here on the right or the left, sorry, and drag and drop an intermediate event on the boundary of the subprocess. Then I need to use the morph tool to convert this to an error boundary event. And this, of course, will also be waiting to catch that same error. So this is going to throw a specific error called podcast cancelled, and this is going to catch that error. And once it does, it's going to actually continue the process. We're not going to just finish everything. We're actually going to do something else. This is the power of these error events. These should be able to catch predictable, repeatable errors and then deal with them in the same way every time. Not necessarily technical errors, but more so business errors. In this case, I'm going to add a user task, and it's going to be complain about Usidore and Chunt. And then I'm going to have an end event that follows that. So if everything goes to plan and Chunt and Usidore actually arrive, we are going to continue this process by selecting the subprocess here, and then selecting a task, and then dropping it here, and then using the morph tool to change that to a service task. And this is going to be called record podcast. And then we will have an end event. Okay, so there's one more thing about this that I want to add, and it's if you guys remember the first slide, it's going to be my personal favorite BPMN symbol, which is the event subprocess. So what I'm going to do is I'm going to select here, which is the actual subprocess. I'm going to drag it and drop it here. Just on the canvas. An event subprocess is kind of unique because it doesn't actually have a sequence flow pointing into it or leaving from it. And to actually create one, I need to select the morph tool here and select event subprocess. Okay, now this should show a little dashed line around here. So what this this subprocess, like all, requires a start event. So I'm going to drag and drop a start event. And I'm going to morph this start event into a conditional start event. Okay. Then this is going to be Dark Lord attacks, and this is going to be a user task called Fight the Dark Lord, and then the end event here. So now let me describe what this is really doing. This is a conditional event, which means it's waiting for a specific condition that may occur. And the very nice thing about event subprocesses are that this is waiting for this event to occur for as long as this process is active anywhere. So as long as there is a token alive somewhere in this process, we are constantly waiting for this event that may occur. So we're constantly vigilant in case the Dark Lord attacks. Now this particular start event is also an interrupting start event, meaning that once this event does happen, we will stop what we're doing, we'll cancel those tokens, and a new token will arrive here, and then we'll fight the Dark Lord. Okay, so now let's have a quick recap on what this process does, and then we're going to go ahead and make all of these symbols executable. So when we start this process, the first thing that happens is the token arrives here, and as soon as the process starts, we immediately start waiting for this condition to become true, the Dark Lord attacks. Next, we will actually move on to this task here. If we spend more than 20 minutes on this task, it will then send another token down here in parallel to go eat something and then end. Eventually this task will complete, and in which case we'll go into this sub-process, in which case we will start here. And we will call our other check weather process, and this will actually wait here until that process is finished. When it's finished, we'll move back. We'll move through here to this event-based gateway, and the event-based gateway will wait for either Usidore and Chunt to arrive, or a message to arrive that says Usidore and Chunt have arrived. But if 30 minutes elapses, or if we're waiting for this message for 30 minutes, we will then go here and send an error message. This error is then caught by this boundary event right here, which then which interrupts this process. Okay, and the task will move down here, complain about Usidore and Chunt, and then end. If we actually do get a message saying that Usidore and Chunt have arrived, the process will continue here. The sub-process will end normally, and then we'll go to record our podcast, and then the process is ended. Okay. So now it's up to us, now that we understand how it works from a BPMN perspective, is to, of course, do the fun part of adding the parameters to each of these symbols to make sure that they actually run in the engine. So let's start doing that. Okay, and to make things a little easier and more visual, I've just gone ahead and added a color to each element that actually requires some kind of execution properties. So we see here we have most of the events here are green, we have the call activity, the error event, and I'll go through each one at a time. The rest of the things will actually not necessarily require any sort of additional properties. For instance, a user task could have additional properties if you wanted, but doesn't actually need any in order to run. So we'll go through that step by step. The first one here I'll do is the conditional start event on the event subprocess. So if I open the properties panel on the right, any sort of configuration you need to make a model executable is going to be added here on this properties panel. And what I'm going to do is I'm going to add a simple condition. This is going to be in a simple expression. So this is hash open curly bracket. Let's say we're looking for a variable called Dark Lord attacks equals, yeah, let's just go with that. So this says if the variable Dark Lord attacks is true, then this condition is met, and it'll interrupt the process, and then we'll end up fighting the Dark Lord. Okay. Next, I'll implement this boundary timer event here. So if I select this, the properties panel should then show a drop-down looking for the specific definition of this timer. Timers can be all sorts of different things, including a date in the future, duration, or like in our case, a specific cycle, because we're waiting every 20 minutes. So if I select cycle, I can put a cron time in here, but I'm going to make things a little easier. I'm going to say R for repeat / PT for period time and 20M for 20 minutes. So this would say that as long as there's a token active on travel to Foon, then every 20 minutes a new token should form here. Once we leave, then this timer ends. So next up is the call activity. So once you select it, you'll see here that we have a call activity type that's required. So in our case, we're going to be calling another BPMN model. You can also call CMMN if you're interested. Once I select BPMN, so a lot of stuff shows up, and the call activity, the called element is actually the ID of our other process model. So if we actually go, if I go to the tab here where we have our other process model, okay, it's called simple demo. So I'm going to copy this, and I'm going to go back to our original model and paste in the called element. We also then have the binding, which shows the latest version, the deployment version, or a specific version that you might be interested in calling. I'm going to go with latest. We can also choose to pass in the business key, which I will. And next up, I'm going to click on the variables tab. Okay, and this should show input and output mapping. So once we call this this process, it will start, and we can choose whether we want to start this with all the variables associated with this process already, or specific ones, or none at all. So by default, it doesn't pass any variables in. So I want to do that. So I'm going to click plus up here. I could add a specific variable, like for instance, I could say take the variable name and call it first name when we start the process, but I'm actually going to select all. Okay, which means that all variables that are currently in the instance are going to be passed to this process. I'm going to do the same here with the output mapping. I'm going to say any variables that are created within that while that process is running, and when it finishes, it'll then copy those back to the current parent instance. Okay. Now we'll move on to the next event, which is the timer event. Once more, we have the same as before, but this time instead of a cycle time, we're going to use a duration because, of course, this will only fire once. So when I select duration, I'm going to just put in PT30M. And now we'll move down to the message event. The message event is a pretty easy one to do. It's waiting for a message to come in from somewhere to find this process instance and tell it that to continue. But what we actually need to do from a design perspective is simply give this a message name, so we know how this message will be sent. So once I select it, we'll see we have a message icon here. There's none already defined, so we'll click the plus button here, and then I'm going to have Usidore and Chunt arrive message. Okay. And I'm just going to move across a little bit now. So next up is the error event. So similar to the way a message works, an error event is going to need some sort of key to give it in order to work. Unlike a message, of course, the error event is both produced and consumed in the same process. A message, of course, always comes from somewhere external. So for here, I'm just going to need to click on the plus. I'm going to give this a message name called podcast cancelled. Okay, and then give it a code as well. In this case, it'll be the same. Okay, so now if I take a look at, so this will throw an error called podcast cancelled, and in fact, it's also looking for a boundary event to catch that exact same error. If I select this and then select from the drop-down menu podcast cancelled, then you can see that it's actually just using the same definition as the throwing event. The final element that needs some sort of execution is the service task. Now, I spent a bit of time already on discussing how these can use to run Java classes as well as external tasks. So for this, I'm just going to select the Java class. I'm just actually going to put in here the name of the logger delegate within my Java project. If you're wondering where that is, it's the same one as I was using the previous example, the weather process. So it looks like this. It just has a simple logger that's created by the Maven archetype. So we have this ready to run. The important part now is actually going and saving this model, this XML file, into your project that we had earlier. So I'm going to open up Eclipse. And we see that I've saved the project hello.bpmn, and the final part of this is actually giving it a proper ID and key. So I'm going to select the canvas. I'm going to select an ID of hello and name also hello. Okay, so now we have an Eclipse project with two models, one that calls the other. And this is actually a time where I'm just going to build this project. So I'm going to right click, run as, Maven install. So everything is going to be built up into a WAR file. Okay, it looks like the build was successful, which should mean that in the target folder we should have this simple demo.war. And if you haven't already, you're going to want to start up Camunda's platform in the background. Meanwhile, if you have already, you should see Cockpit here with a bunch of other processes we've been deploying with the other tutorials. And there's 4 of them right now. So you want to add an update basically, which is going to add an additional one. As usual, we're going to take this WAR file that we've created, simple demo, copy it, and then open up the directory where the server is. That's server Wildfly standalone and deployments. And in the same place that we pasted this in the previous demo, we're going to place it and just replace the file. Okay, so that will then redeploy the new process. And in fact, if we go to Camunda and refresh Cockpit, we should then see hello, which is our new process. There it is in all its glory. Okay, as you can see, there's not much happening right now with it. But of course, we can start a few instances now and step through it and see if all of this works. So just like in the other tutorials, if we want to step through a process or start it or anything like that, like any direct sort of using the process, we actually need to go to task list. So for that, I'm going to click on the house in the top right and click on task list. I'm going to open it in a new tab because that way I can switch back and forth easier. And once I open here, we can see the filters here. I'm going to select all tasks. So now when I click on start process in the top right, I'll see my process list and there's hello. So I'll start that by selecting it and then selecting, maybe I'll give it a business key of 12 and then start. Okay, maybe I'll just start a few of these. So once more, I'm going to click on start process, hello, 13, start process, hello, 14. I'll explain what the business keys are used for a little later on, but for right now, we should see that we have 3 tasks, which are all at this point in the process. Okay, and I think if we click on this form, this is a generic form that's generated if you actually don't define any UI. So I'm going to claim this form, which means it's now no longer read-only. I can now complete it. And I'm going to click complete. Okay. So now that's gone from the list. If we want to know what actually happened, of course, we have to go back to Cockpit and refresh this page. I've refreshed by clicking on history. So here we can see that we have 1 task is waiting here. Sorry, 2 tasks are waiting here. We have one that has actually finished this and is inside the sub process. So let's take a look at this in more detail. So if I select this, I can see the instances here, and I can click on this to see more details about it. And then we can see the way it's traveled, and that it's traveled into this call activity. And we can actually find out exactly which instance was called and look at the history of that as well. So I'm going to select the call activity, select the call process instances tab, and then select the ID of the instance itself. I'm going to open a new tab as well. So then, of course, we can see that we started the process, we checked the weather, and it ended up right here. Okay, and then, of course, it came back, and now it's waiting for a message or 30 minutes to expire. So let's do the easy thing first. Let's try and send a message to the engine. So this is where the business key comes in. I'm going to send a message to the engine using REST API, and I'm going to use the business key 14 here as a correlation key. Okay, so let's go do that. So there is another video that talks more about the REST API in a lot more detail, but for this I'll go through just the scenario in which we want to send a message here. I'm going to go to the docs at docs.camunda.org, and then I'm going to click on Reference, REST API, and then I'm going to go to Message. So we have one method which is called correlate, and I'm going to click on the example here to bring us down to the bottom. So as before, this is going to be a post call. It's going to use the endpoint message, and it's going to need a bunch of other bits and pieces that we'll get to in a moment. Let's start by opening up our REST client, which in this case is going to be Postman. So there it is in all its glory. So as we said, this is a post call, so I'm going to change this to post. The REST endpoint is localhost 8080 engine REST, and the call itself is called message. So we also need to add a header, which is content type, and it's application JSON. Okay, and now you need to go into the body and actually click on raw and add the JSON. Now in this case, I'm going to copy this. I won't need it all. I'll just copy it and I'll explain as we go along and paste it in here. So I'm going to get rid of everything except for the message name and the business key. So the message name is pretty obvious. If I go back to my model, I can see that if I select this, I gave this guy here a business key, sorry, a message name of Usidore Inchunter arrives message. I'm going to copy that and I'm going to send it here. Now the business key is more interesting because of course it's possible that we have hundreds or maybe thousands of instances all waiting for this message at the same time. And one of the ways in which you can find the specific instance you want to send your message to is by using a business key. So for instance, if I put 11 in there and send it, it should break theoretically because there's nothing waiting for it. So it then says that no process definitions match these parameters. Now we know that business key 14 is waiting for this message. So if I change this to 14 and click send, okay, that was good. We got no content, which is actually what we want, which means the message was received. To check that, we can go back to our web browser, go back to Cockpit, and refresh this page. Okay, and now we can see that this process is actually finished all the way through. So there is a lot more to learn, of course, in BPMN, and if you're interested, of course, we have the book Real Life BPMN that's been published in several languages, including German, English, and Spanish. We also, of course, offer 3-day trainings where we can understand and apply these, and we also offer a more technical training if you haven't already heard of that as well. So feel free to go to camunda.com, and if you're interested in further explanations, we can organize something. Thanks a lot. Bye-bye.